Thanks for joining the Soar Cast, where we talk about drones, manned aircraft, and satellites, and how they relate to geospatial products found on the Soar platform. Welcome everyone to the Soar Cast, and today we have some interesting guests. We're talking to Andrew Dedman with Stratus Imaging out of Western Australia, and we're also talking to Tristan Steventon with Stevtech in Peak Hill, New South Wales. And they're both working in the ag space, and they're both partnering together with something called Taranis Ag, which is pretty much the highest level ag application for drones that I've seen. And that'll be the second part of the interview. And really the first part of the interview is just saying hello to our guests and learning about what they're doing in the space. And then we'll get down in the weeds. I promise there'll be plenty of, phrases or jokes about agriculture if I can manage them. Anyhow, welcome, Tristan. You're with Stevtech, and can you tell us how did Stevtech get started, and what you guys are doing?
Yeah, thanks, Darren, and great to be here. Stevtech started in about 2016. I grew up on a farm when I was sort of growing up, and left that farm just after school to go to the military. And at the end of the military career, I realised that a lot of the stuff that we were focusing on in the military, robotics, artificial intelligence, resource scarcity, and a bunch of other things, really applied to the agricultural sector. So after my sort of 20 years in the Australian Army, I got out and returned to the agricultural sector and kicked off Stevtech, which was a fortuitous timing because it was at just that moment that one of Australia's most desperate droughts occurred. So we've been battling through that for the last 3 or 4 years, but that's sort of how we started. And what we do is essentially we scour the globe for some of the most advanced tech we can find in terms of drone or geospatial tech, and then we make it really simple and really accessible at the ground level. So we sort of fulfill that niche between those tech companies that are building really cool stuff like Taranis and then that farmer who wants to apply that tech in his paddock. We basically translate that from advanced tech into simple solutions.
Oh, brilliant. Thanks, Tristan. And Andrew, you are with Stratus Imaging. You've been a guest on the Soar Cast before, and you are also the Australian distributor for Taranis Ag. Can you tell us, why not, tell us a little bit about how you got into this space, and also give us an overview of what Taranis Ag serves.
Thanks, Darren, and thanks for the invite back. It's good to have a second bite of the cherry and come back and have a chat. So like Tristan, we started back in 2016, and basically the same journey. We looked at the global tech market and see where technology was going within ag. There was a lot of I found it very disjointed between what's happening on a farmer level and what's happening at a tech level. It just didn't seem to be a single package, and that's what we brought. What we think we bring to the market is that continuity from tech to the farmer and the application, because farmers want to be able to use the tech but get something out of it, make a decision. And that's where we partner with Taranis, which is an Israeli company. They've been going for, I think, about 2012-13 from memory, and they use high resolution imagery down to 0.3 of a millimetre, and we'll have a look at that a bit later, to actually start to look at insects and disease and weeds within the image. So it's not a normal image where you would look at plant health and apply it across the field. This is actually looking at for individual weed species and insects. That's really exciting. Tristan over in New South Wales has flown a lot of hectares for us, so he's very familiar with the technology as well. It'll be good to explain that in a little bit more detail later on.
Yeah, thanks for that, Andrew. And certainly warrants a bit of time. I think you threw out those numbers, the 0.3 mils of, ground resolution. And the things that we'll learn about how that tech is working, it's AI driven, in fact, to do all sorts of things just in the agricultural space. I'm sure it could be applied in other industries, but they're certainly just focused, or this tech is focused on that. Before we go back into imagery, and something we covered in the last interview with you, Andrew, this is mostly going to be on the imagery and how the imagery is used for analysis and improving yield and those types of things. But there's other applications, and we did cover using drone swarms and how they work. But if one of you can just briefly outline, beyond imagery, how else are drones serving agriculture?
You got this one, Andrew? You want me to go ahead with it?
Yeah.
I'm happy to take it. Well, obviously, a lot of what drones do at the moment in agriculture is to do with imagery. But I think it's the add-on of things like artificial intelligence and machine learning to that imagery, which is going to have the biggest impact. And what I mean by that is, I suppose, once you've got that image, once you've got that data layer, it's not necessarily an image anymore. It's just data points geospatially represented, so data points across terrain. And then you can use that for all sorts of things. One of the biggest things that we found is the need for corporate farms, so big farms that need to talk to boards to generate statistics. And the use of imagery and artificial intelligence or machine learning to be able to turn that imagery into statistics so they can understand how their farm is trending is a really huge trend that I'm seeing. Obviously, there's other areas like the use of thermal imaging for canopy temperatures to understand whether or not to water, how to irrigate, when to not irrigate, when you're over irrigating, when you're under irrigating. Survey is a big thing in some parts of agriculture where you need to have nice flat fields. But in Australia, I think the most common use of drones at the farm level is probably just to check on things that you can't be bothered going and having a look at. So if it's going to take you like half an hour to go around all your troughs or whatever, you can sit on your back porch, or the farmer sits on his back porch and sends the drone around. That's sort of, in the Australian context, what drones get used for a lot.
Well, that's good to know, but it certainly serves a purpose, and would certainly save guys' times. I know it's it just takes time to get out there, check fences, like you said, troughs. That's another big thing, and we see that in farms. In our other part of our business, in terms of the geospatial stuff, it's the Internet of Things, and I might touch on that a little bit, but having that data and feeding it back, sort of real time, being able to monitor things, and I think drones sort of have a place there, and so maybe I'll touch on that. So going back to imagery. I have a drone. It's a store-bought drone. Seems to do pretty well and produces RGB, or red, green, blue images. I want to make this fairly specific, but how is a farmer going to use that image of, say, a canola field or a wheat field? How is he going to use that type of image?
I think it comes down what the farmer wants to achieve, and a store-bought drone sometimes does not achieve what the outcome is. So, as you mentioned, an RGB standard camera is not going to give you any more than an aerial view of a farm. That is very, you can get information from that, but once you start looking into plant health and water stresses, as Tristan mentioned, your standard camera is not going to provide that level of data. So that's where we get into the multispectral space and look at stuff that's outside the visual band, such as near infrared and far infrared, to look at water stress and plant health. So they do have their place, but we always look at the use case. What is the farmer to achieve, and what decisions is he trying to make, or what challenges is he trying to overcome?
Yeah, and I'd add to that,
okay,
you
cool.
can have the drone. That's no worries, and collect some pretty high resolution data just with off-the-shelf drones. But it's the system that you actually need. So that's where Andrew and my company sort of focuses on producing that system. So imagery is only one part of the puzzle. There's all the analytics that need to go with it, and they can cost a lot of money to get that developed and get that rolled out and subscribe to that or whatever. But it's really the system that produces the effect, not the individual camera or the drone.
And that actually brings something to mind. I know that when I spoke with Andrew, he's been, working with modifying drones, accommodating, sort of the need or the end goal by modifying a drone for some way. So I just I know it's hard to put a number on it, but there's probably obvious time saving and as well dollar savings if you were to use sort of a service or something that is supported. Um, I don't know. I don't know if we can put a number on that, but I think it's just a learning curve kind of thing. Maybe we can just get that out there that working with somebody who's got the technology and the know-how is probably going to save you a bit of time. So I like what you guys said about putting the information out there in a way that those guys use it, and then as well they can relate that to board members and such. Because I was speaking with somebody earlier today, and they're in the construction, industry using drones, but the way that those guys use data is entirely different than we might use it. Okay, Tristan, you talked about thermal and the use of thermal drones. So I know you can now, even thermal drones or integrated drones. You can buy drones that have integrated thermal cameras. Tell us just a bit more about how thermal's used in ag.
It's increasing in its use at the moment. So I don't think it's used a lot in research at the moment. But I don't see a lot of it being fielded commercially just yet. But certainly, let's take a use case, an example in Australia. A canola field, for instance, would a cotton organisation, a cotton crop in Australia gets irrigated pretty heavily. One of the highest input costs into cotton is water. So water costs a lot in Australia where we irrigate, and there's in-crop sensors, there's canopy sensors you can put in the crop to have a look at specific parts of the canopy. But if you have terrain variation or any number of soil variations or whatever across the remainder of that paddock, you might not have a constant thermal temperature of that canopy. So getting a drone over with the correct thermal sensor that can define very specific changes in temperature might give you really good decision points to make decisions on irrigating, whether you need to irrigate now or whether you can wait another 2 or 3 days to irrigate, or whether you can wait another week to irrigate, which might save you an irrigation cycle, which might save you thousands and thousands of dollars in water. So I see that's where thermal is really going to make a big impact in agriculture, but I don't see it necessarily being rolled out commercially in great numbers just yet in Australia, but it might be elsewhere in the globe, I'm not sure.
Okay, yeah. Going a little bit more into, I guess, the multispectral space. So both the sort of your near infrared, and then even on the other side, the ultraviolet and even the far infrared. The most common, image composite. We use the phrase composite to indicate it's there's a bit of an algorithm behind it. Is NDVI to show when there's plant health. Which is basically using red and green, and then it's the ratio of the amount of reflected light. But I'm curious, what are the other composites that are being used in the ag space?
Should I take that one, Andrew, or you want me to?
For us, we use NDVI because we think it's a great correlation of plant health and plant stress. There is other algorithms. There's a lot of different indices that people do use, but it depends on what the farmer's trying to achieve, and a lot of it's around stress of the crop. And NDVI is a great composite for that application. There is chlorophyll maps. There's NDRE, which uses the red edge band, which looks more at chlorophyll type components. We haven't had a lot to do with that in that space. As I mentioned, NDVI is what farmers typically use and understand.
We use a bit of NDRE in tree crops over here. We use that through a South African company we're also partnered with, similar to what we're doing with Taranis and Andrew, and it apparently penetrates further into the foliage than just the standard NDVI algorithm on the back of they use different light sources, I suppose. So the red edge component of NDRE penetrates further into the foliage and gives you a better visualization of the health of each individual canopy that you're looking at, say like a citrus tree or whatever.
Okay. And I think it might be fair enough to bring up the point of even cellular sort of resolution. So, we're dealing with drones that, you fly them low enough, the resolution's high enough, you can get really incredible resolution. But the tractor is still, a couple meters square, 10 meters square or something like that. So what is the preferred, I guess, cell size that you guys are working with? Obviously, it's going to change by the crop, but when you disseminate data to a farmer, what cell size does he want to work with?
Like you said, it really depends on what his equipment is. So that's where companies like Stratus Imaging and Stevtech come in to understand the exact requirement, the exact setup of that farmer, and then match the data to that farmer. There's no point him having the most high resolution premium data set, which is going to cost him the earth, and then he can only apply like 10 meter or 50 meter squares in that when he actually goes to apply that. So that's the key part, I think, that's missing in a lot of this. There's a lot of money going into developing tech, but there's not a lot of that translation of tech to practical, and that's where the organisations like ours and Andrew come in, and we say, right, well, actually, what you need, listening to what you're saying about what your needs are, I think on the spectrum of things, this is what you need. And in the case of the Taranis system, it's really good because it's a layered system. So it's not just drone data. It's not just high resolution drone data. It's everything from 10 meter satellite to 1.2 meter satellite to 10 centimeter high resolution stuff that comes from either a plane or a drone. And then that really, really specific high resolution drone data where you can find individual insects and weeds and all sorts of things. So it's one of those layered approaches that allows you to tailor exactly where that farmer is at, and tailor a package to his needs, essentially.
Okay, that's good. Gives us a good chance to go into what Taranis Ag is doing. I came across a few phrases or words: emergence, nutrient deficiency, insects, and disease. So, and those are the types of things that the technology is looking at. Emergence. Let's just clarify that term. What is emergence speaking to?
So it's looking at the amount of plants that emerge from after seeding. So emergence can be difficult depending on the type of crop. Precision planted crops like corn and soybean are easy to do for emergence, but once you start getting into wheat, barley, and canola, where it is basically seeded from an air seeder, you don't get a uniformity to try and count the emergence. So you can get it close, but it's not as accurate as precision planted crops.
Okay, I saw a term on the website, and it speaks to the whole subject, I guess, which is digital farms. So obviously the drones bring us digital data. What else is using the data that's coming from these drones?
So one thing I mentioned earlier was around having to have all this data, but the farmer's got to be able to make a decision with this information. So with the Taranis system, we can capture the weed information down to individual weeds, and we can create a heat map out of the weed pressure. And then we can create zones, and depending on the size of the property, we can tailor the amount of zones, and then that information is then put into a prescription, and then that can go into a tractor for variable rate application. So as Tristan mentioned earlier, most sectional booms are around 50 to maybe a metre, 50 centimetres to a metre. There's no point in providing data down to 8 or 10 centimetres because the machine can't handle that information. So the system will then create zones based on what is applicable to the farmer, so they can go out and do targeted spraying.
I guess it's not just the farmer, though, that's interested in this stuff in terms of digitising farms. The biggest uptake I find is with agronomists. So consulting agronomists, essentially, who go from farm to farm to farm, have in Australia, they might have anywhere from 10 to 25 customers that they have to understand exactly what's happening on each farm. Digitizing that, as in giving them reports that can come out of Taranis or satellite data, or just a cogent way for them to visualize that digitally, means that they can get across heaps more terrain in a way that still takes absolute precise care of each customer without having to be on that quad bike, that motorbike, roaring through fields for the entirety of his working week. He instead can outsource some of that labour-intensive scouting to other sources, be they satellites, be they drones, whatever. And the way that I sort of conceptualise that is based on my previous career in the military. When you're on the ground and you're in the face of it, everything's analogue. You're seeing everything as it's happening. But then when you step back and you take command of things at a higher level, you have to digitise that. You have to understand that in a digital sort of format. So you have to understand terrain, airspace, reports that are coming in, whether they're not in a digital format or not. You have to digitise that so that you can make more decisions across a wider area. That's essentially what we're allowing the farmer to do. You can go from an analogue kind of perspective of the farm, or even the agronomist, an analogue perspective of each of his farms, through to being like, the commanding general who can sit back with a digital perspective on what's happening, make decisions on data, and then move on. And for those agronomists that we're working with, we're finding they can increase their rate of effort, they can increase their return by bringing on more customers, because they can get across more country a lot quicker and a lot more accurately. Okay.
The technology behind Taranis Ag. We'll do a two-part. So if I'll let Andrew take what the hardware is, how it works, and how it's providing data, and then Tristan, afterwards, maybe you can tell me how that all works in the field. Just describe a typical operations flight. So over to you, Andrew.
So we'll start with the platform. So when a customer comes into the platform, they get satellite imagery. They can also order premium satellite imagery through 1.2 metre Airbus imagery. And then we can go down to the 8 to 10 centimetres with the drone and DVI. And then we go into what we call AI2, which we'll talk about now. So the AI2 is captured with a Canon camera, a normal digital camera, mounted horizontally in a pod that's mounted underneath a heavy lift drone. The drone is typically around 12 metres above the ground, 12 to 13, depending on the crop, so about 40 feet AGL. So it's fairly close to the ground, travelling at between 30 and 35 kilometres an hour. The drone doesn't stop to take the images. They continuously taken. So it typically takes an image every 45 to 60 metres. So once we look at the captured data, it works out to about 1 image per acre. Tristan mentioned earlier about an agronomist would go out and do a scouting run over a lot of hectares. This basically does the same thing, but it's covering most of the field, 1 image per acre, which is about 2%. But it also covers the inside of the field as well. So typically an agronomist or a farmer can go into a middle of the field where there could be an outbreak of disease or a weed or a type of insect. So the drone will cover that as well. The images are then uploaded to the Taranis system, and then it goes through a fairly complex AI identification process. So every image is analysed 4 times. So each image is analysed for nutrients, insects, disease, or weeds. If there's enough information within those images, then it provides an insight onto the platform where a farmer then can go in and look at how many weeds per metre square have I got, what type of weeds, what insects have I got, how many insects have I got, and nutrient as well. With the nutrients, it's looking at the symptom. It's not going to tell you how much nitrogen, as an example, you need to put into your field, but it'll tell you that there's a nitrogen deficiency based on the symptom of the plant. So you can then start to target where you go and look for, if you've got a disease outbreak, you can go and look at that particular part of the field. So these images take about 12 to 24 hours to process. So it doesn't take long. And Tristan could probably vouch that the imagery that comes back is unbelievable. We can see insects, bees and flies and moths that are sitting on a leaf. You can't see the exact type of moth it is, but you can see that there's a moth there. You can distinguish what insect it is. So the AI is pretty powerful, very precise. When Taranis started, they analysed millions and millions of images with agronomists to identify exactly what a certain weed looks like, or a certain insect or a certain deficiency looks like. And then the machines, the AI is trained. So yeah, that's it in a nutshell. People are surprised how it's captured. The camera is actually sitting horizontally; it's not pointing down. So there's a mirror system within the pod that moves at the rate at which the drone is flying. So at a split-second point in time, the focus and the camera move at the same speed of the drone. So when it does take the picture, everything is standing still for a split second. And that's how the image is captured in great clarity. So that's an overview, but it's pretty amazing. When you see the back-end stuff of how these guys look at the images, it's pretty impressive.
And Tristan, maybe you can. Do you? I think you said you had the gear right there, and even if you could hold it up to the screen as you're describing it.
I've got the pod there in the back. I'll
give,
grab it.
Okay, yeah.
So that pod weighs about 3.5 kilos with a camera attached.
Back on. Yeah, so you can see the pod here. It's about a 2 kilo bit of equipment which dangles off the. Let me take the thing off, Andrew.
Yeah.
So it hangs off the bottom of a Matrice 600 drone, which is essentially the DJI hexacopter, is what we use. And as you can see there, the cannon is essentially shoved in the back there, parallel to the ground, and it uses a system of mirrors to basically take those images, if you can see that from where you are. So it's a high-end sort of camera, full frame sensor, decent lens on it, and a system that can log exactly where it is at any one time in the paddock, so that that the system can make sense of it once it comes back for post-processing, I suppose. So so that's the device. It's a little heavier than most devices that we carry in a sort of agricultural imaging sort of sense, but we can do vastly more hectares than we can in a traditional sort of multispectral sensing fashion, because of exactly what Andrew said in terms of the fact that it's just taking samples around the paddock, much more samples than an agronomist would take, but it's not taking the whole paddock. It's taking 2 or 3 images per hectare, an image per acre in American. So I guess to your question, what we do when we go out there, we basically head out to whichever farm that Andrew sort of ascribed us to, and we'll set up our Matrice 600 with the pod on the back of it. In order to power the Matrice 600, you've got to have a fairly decent setup in terms of batteries and generators or inverters and batteries in the vehicle. And what I normally do is I normally start the equipment up, and then some widget doesn't work for me, and I have to call Pete, my main pilot. He's my head pilot, so I don't get out as much as he do. Give him a call, he'll put me in the right direction, and then we'll get going again. And then it's very simple. We have a flight planning app, which we basically it's an app that allows you to terrain follow. So that as Andrew said, it's very low to the ground comparatively. It's 15 or odd meters from the ground. So in Australia, we have things called gum trees, and I know you have power lines over there. We also have them, so they are at a similar height. So you've got to just be a bit careful about how you plan the missions, and then you rip into it, and it's, as I said, vastly faster. So with a fixed wing platform doing traditional orthomosaic, like NDVI orthomosaics, we'd probably get through around 500 to 700 hectares a day. That's with a fixed wing at 120 meters, getting 10 centimeter resolution imagery. With the Taranis pod, over summer we were getting through up to 1,000 hectares in a day per drone. So it's remarkably remarkably quick. And that is probably one of the key points in Australia, which has limited adoption in Australia, is that the slow nature of acquiring drone imagery on such large fields. Like in Australia, it's not unusual to have 200 or 300 hectare fields. So what's that in? Times that by 2.4, and you've got how many acres those fields are. Those individual paddocks can be that big. And so in Australia, one of the limits to adoption is the fact that drones just cannot get across as much terrain as they need to in a day. But with this pod, we actually can. We've got, in my business, we've got 2 of them, and we will be able to, this winter, we should be able to get across, up to 2,000 hectares a day as our little business, which is times that by 2.4, and that's how many acres we're getting across. So yeah.
Mm-hmm. Yeah, well, that's brilliant, guys. I think we got through most of the questions, and in terms of what it's capable of, and when we'll definitely source imagery and video that Andrew's provided us as sort of a backdrop for this, for those who are watching. We've come up against the end of our show. We've I'm sure there's more we could cover in that space, but it's been really great having you guys. And thanks for coming on the show.
Appreciate it, Darren.
Thank you. Thank you.
That's all we have time for today. Tune in to our next Soar Cast for more discussion on geospatial products found on Soar.